Hey everyone, welcome back to the channel. Today I'm diving into the fascinating world of AI agents again with another exciting build. But first, here is what we are creating in this video. Imagine this, you search for critically analyze the Indian economy over the last 5 years and the agent does all the heavy lifting like researching, analyzing, generating insights and all of that stuff. It even creates the charts, key takeaways and a detailed report all in under a minute. Oh, and downloading the report is as simple as clicking on this button. You don't need to be a coding wizard to follow along, but if you have seen my previous video on AI agents, that will give you a head start. Don't worry though, this video is beginner friendly and all the code is shared in the description below. Whether you are here to build your own AI-powered SaaS application or just want to grab the code and start using this tool right away, this video has got you covered. So let's get started. Now, before I build the front end of the app, let's start with the heart of the application, the agentic workflow. I'll begin by cloning the research workflow that I built in the previous video. I'll leave a link to this under the video. I'll open this up in LangGraph Studio. A couple of things here. It requires Docker to be running and it is looking for a .env file since we have mentioned that in the langgraph.json file. So I'll click this button here and open it up using VS Code. In the langgraph.json file, we can see that we have specified the .env file. So I'll add a .env file at the root of the project and also add a OpenAI API key since we have chosen OpenAI as our LLM provider when we build this agent for the first time. With that, I'll reopen this. This workflow includes two key agents as you can see. The research agent which gathers the data and the chart generator which converts that data into visualizations. In this instance, we'll not be generating Python code, rather we want the chart generator to output JSON. While preparing for this video, I found that GPT-4o performs more consistently in that task. I'll modify the chart generator code. We'll use GPT-4o instance in this case, as we said. Note that earlier we used GPT-4o mini for both the researcher and the chart generator. For that, I'll create a separate LLM instance called LLM JSON that will use GPT-4o. And this LLM will be used in the chart generator. For research agent, we are sticking to the 4o mini as that works just fine for the online search and summarizing the results. We'll give it a system prompt that is similar to the previous video where it can ask additional information back to the researcher if required and outputs a valid JSON in a specified format. So again, here is the idea. The research agent gathers the data and the chart generator transforms that data into a specific JSON format. That is an array of charts where each chart includes the type of chart like bar chart or bar chart and labels like x-axis label, y-axis label, etc. and all the values for each chart. Also a footnote that summarizes all the key findings. All of the code will be shared under the video so you don't have to pause the video here. You can just follow along. We don't need the Python REPL tool here. Rather, we'll create a JSON validator tool. It is a Python function that takes a string and tries to load it using the inbuilt JSON package to see if the string is a valid JSON object or not. I'll have to import the JSON at the top as we did in the last video. I'll use the tool decorator and the docstring to provide additional metadata so that when we bind this tool to the LLM knows what this tool is about and how to invoke this tool and all of these things. Using this JSON validator tool ensures that the output string generated is a valid JSON object and is ready to be used by your front-end web application. Before we move forward, let's test the workflow. I'll ask critically analyze US economy in the last 5 years. As before, the researcher generates multiple tool calls using the DuckDuckGo search tool. I can see that I'm getting multiple rate limit exceptions from the DuckDuckGo tool. Hence, I'll switch over to Tavily search. I'll add Tavily Python in the requirements and save it. I'll also add Tavily API key in the environment variable. And you can get a Tavily API key for free from their website. I'll import the tool from the LangChain community package and I'll create an instance of the tool like this and I'll bind this tool to the researcher in place of the DuckDuckGo one. I'll ask another question, demographic dividend of India, and we can see the charts array in the JSON format. With the agents ready, let's move to our web application. This is going to be a simple Next.js application, so I'll not go over the details of setting up a Next.js application and stuff like that. I'll leave a link to the GitHub repo under the video. Here I have set up a Next.js API to interact with the agents. It receives user query from the front end and we are going to use the LangGraph /remote npm package to invoke the graph that is running on the local port. We'll copy the port from the LangGraph Studio and paste it here. After it receives the response from the remote graph, it unpacks the JSON and makes sure the JSON is a valid JSON using the parse JSON string function. The thing is that sometimes we get the JSON markdown, and this function strips down that JSON markdown and parses the trimmed string as a JSON object before returning it as a validated JSON object back to the frontend. Now for the frontend includes a simple input for user query, a search button that sends the API call using the onSubmit handler function and shows a loading state while awaiting the API call. Inside the onSubmit handler function, it's a simple fetch request, and on receiving the response, it is going to parse that as a JSON object that includes all the charts and findings. For each chart in the chart array, a dynamic chart component displays the results. So if I go inside the dynamic chart component, in here the dynamic chart component uses the ShatCN chart component to display the JSON data. It has components like chart container, bar chart, x-axis, tooltip, and things like that. I'll leave a link to the ShatCN charts docs under the video for your reference. This is basically using that syntax to display the data that we have received in the JSON format from the research agent. So back onto our homepage, when we click the search, the input query is sent to the API, and once the response comes back, the results are displayed as this interactive chart, and any additional findings are shown as text. Here is also a quick disclaimer reminding the user to fact check the information before sharing the content to larger audience. Finally, we'll spin up the app. For this demo, I'm running it locally, but you can deploy it onto any hosted Python environment using Docker, as the local instance is running on Docker itself. I think that means no vendor lock-in. That said, if you are looking for a serverless option, then LangChain provides that option for easy deployment of LangGraph agents. But in my case, I'm going to stick to the local, as local is easy, free, accessible, secure, and all of that good stuff. Once it's live, we will have a fully functional app that converts research into visual insights in seconds. Before I forget, I'm using the HTML to image npm package to download the report as PNG. It comes with a toPNG function and integrates very easily with Next.js application. This function takes a page element and returns a base64 string. I'm grabbing the div container that contains the report using an ID called capture. Also, I'm automating the download by creating an A tag and giving it a file name, a trick that I used in one of my videos almost about a year ago. And there you have it. In this video, we have set up a research and a chart generation workflow, integrated it into a Next.js application, built a frontend to display the results beautifully using our favorite ShatCN UI components, and all the code is available in the description, so feel free to try it out. Let me know your thoughts and questions in the comments. Thanks for watching, and I'll see you in the next one.